Welcome back, my students, to the third part of the amino acids. It is reaction of alpha amino acids. This is the formula of the alpha amino acids. We have two functional groups, amino group as a basic, and this one it is C double bond OH, it is carboxyl group acidic. So we have reaction for the amino group and then another reaction for the acidic group, and then for both, then the fourth one it is the amphoteric properties. We start with the first reaction. It is the reactions of the amino group. So the reaction of this group NH2, it is base, so it reacts as a base with acids. So the first reaction as a base, like amines, with acetic acid or acid chloride or acid anhydride. Do you remember the reaction of the amines with the carboxylic acid or acid chloride or acid anhydride? It is the same. What is the rule? Yes, you have to remove, this one is example for the amino acid and this is for the acid chloride. Yes, what is the rule? The rule is you have to remove H from N with what? With Cl from the acid chloride. Okay, this one is removed as HCl. H from the N and Cl from the acid chloride. Yes, remove them as what? As HCl. What remains here, you have to join them. From this side, from the acetyl chloride, we have CH3CO. This is the black one, CH3CO. From the glycine, the amino acid, we have NH because one H is removed. So the rest here is NH. Then CH2COH, NH, CH2COOH. The second type of the reaction of the amino group with nitrous acid. In the nitrous acid, this is the nitrous acid, we can write it HNO2 or you can write it OH and double bond O. Again, HNO2, the same. HNO2, or you can see it like this one, they are the same. What is the rule if you have nitrous acid? Yes, just remove NH2 and replace it by OH. How this reaction takes place? This N with this N are removed as N2, nitrogen gas, and this H2 with this O is removed as H2O. What remains here? It is OH. So this OH replaced the NH2. Here it is the OH. So the general rule now, if you have nitrous acid, just remove NH2 and replace it by OH. That is. And here we have the side products, H2O plus the nitrogen gas. This example, this one we call it glycine, and this is the nitrous acid. The compound that is produced, we call it the glycolic acid, and here we have the nitrogen gas. We use this reaction in our life to analyze proteins, to determine the amount of nitrogen in that proteins. Why? Because we need to know how many amino acids inside the protein. When you add nitrous acid to the protein, it gives us the nitrogen gas. You have to know how many moles of the nitrogen gas. Each mole of the nitrogen gas represents the one amino acid. That means if you have maybe 1000 moles of the nitrogen gas, that means you have 1000 amino acids inside this protein. 2000, 2000, and so on. So this reaction in our life, we use it to analyze proteins. Why? To know the amount of the amino acids inside the protein. This one, it is the first part, the reaction of the amino group. The second part is the reaction of the carboxyl group. The carboxyl group react with alcohol forming esters. So here we have to add the acidic medium, and this process we call it esterification. So carboxylic acid with alcohols react with each other and give us the ester. The process we call it esterification. So this is the example here. This is the carboxyl group, and this is the alcohol. Alcohol we have OH, and the carboxylic group we have COOH. In this reaction, OH is removed from the acid and H from the alcohol. H and OH are removed as H2O. What remains here? You have to join them. So this is NH2 CH2CO. This is NH2 CH2CO. You have to join from the oxygen, from the same place that you remove hydrogen. So I remove hydrogen from here. So you have to join OCH3. You can write the bond or without the bond, it is known, so no problem in this case. So this one we call it glycine, and this is methanol, because we have one carbon atom, it is the methane, and this is ol for alcohol. That give us the compound, it is ester. Ester here, it is the functional group for the ester is COO. COO without H we have carbon, so this is ester group. If you have COO, so this is COO and H, this is carboxyl group. But if you have COO without H here, it is C, now it is carbon atom. So in this case you call it ester group. And in the ester we have the name 8 or weight. So how can you name this one? Yes, this is, as a branch, we call it methyl. This is the methyl. Then we have two carbon atoms, we call it acid, then add 8 as a suffix for the ester. And this is amino, we call it methyl amino acetate, because we have two carbon atoms. Or you can say this is methyl amino meth. So this is ethane weight. You can write, and instead of acetate you can write ethane weight. It is the same. The second reaction of the carboxyl group is with barium hydroxide to give us primary amine. So this is very important. This is one method of preparing amines from amino acids. So amines are prepared from amino acid by reacting with barium hydroxide. This is the general rule. This is the alpha amino acid, and this is the barium hydroxide in the presence of heat. Just remove C double bond OO. This C double bond OO is removed as CO2. What remains here? We have H. You have to join it with this C. So how many H now you have? Yes, I have 2 hydrogen atoms. Here we have 1 hydrogen, and this is the second one. So we have RCH2. H and this H, they are CH2. And here we have NH2, so the same. Yes, in this reaction, if you have barium hydroxide, just remove COO as CO2 and write the rest of the compound. It is the same, just this H is put it here with this carbon, so you have CH2. Example for this one, we have CH3, CHCOH, NH2, so this one we call it alanine with barium hydroxide. When you see barium hydroxide, just remove COO and write the rest of the compound. So the product is here, yes, it is CH3CH and this H, so CH3CH2, and CO2 is removed, COO removed as CO2. The rest of the compound CH3CH, and this is CH2 because we have 1 hydrogen here, I put it here, and then we have NH2. This one we call it alanine, so it gives us, yes, 2 carbon atoms, we call it ethyl, then we have the functional group here, it is the amine, or you can say amino ethane. This is, the reaction of the carboxyl group. So we have two reactions. The first one is with alcohol to give us ester. The second one with barium hydroxide to give us what? The primary amine. So the reaction of the carboxyl group. Now the third type of the reaction of alpha amino acid, reaction of both amino group and carboxyl group. In this reaction, we get deep blue color if it reacts with the copper ion. So this is the example here. We have glycine and the another molecule of glycine react with the copper ion here. Just rearrangement the glycine here. Rearrange the glycine in this case. Look, I will start from here. This is NH2, this is NH2, CH2, CH2, C double bond O, C double bond O, O and remove H. Yes, O, then remove H. Yes, remove H and write the bond. Again, NH2, CH2, C double bond O, O. NH2, CH2, C double bond O, OH. Remove H and join this O with the copper. And the same from the other side. I put it here from down, here from up. So NH2, this is the second one, NH2. Yes, follow me. NH2. CH2, so this is CH2. C double bond O, so this is C double bond O. Then we have O, H. Remove H, yes, and join with what? With the copper. So this is OH, remove H. H and H are removed as H2. So this is, we call it the cupric glycine, because this is glycine and this is another glycine. So we have this compound, it has deep blue color, we call it the cupric glycine. Okay, the fourth reaction of amino acid, the amphoteric properties. What does mean amphoteric properties? Amphoteric because we have acidic group and the basic group in the same molecule. So amino acids are amphoteric because they have two functional groups. One of them is acidic, the other is basic. So they react with acids as a basis and with bases as acids, forming salt. Again, amphoteric properties, it means they react with acid as a base and base with acids. Why? Because they have two functional groups in the same time. First, with hydrochloric acid. So this is the hydrochloric acid, so it is acid. So now the amino group reacts with the acid. Now here we have NH2. This pair of electrons will join with this H, so it gives us NH3 plus. Then the rest of the compound CH2 COOH, and here we have the Cl. Cl goes outside as what? Cl minus. So this one NH2 join with what? With H. This is NH3 plus, and the bond between H and Cl is put it here as a negative electron. Okay, but this is the right reaction. But unfortunately, in the ministry book, it's written in another way, and we have to follow the ministry book in the exam. In the exam. Here in the ministry book, this H removed with this OH as H2O, and he replaced the OH by Cl and put it here. And this is, you have to follow it because it's in the book, but this is the right reaction. Again, you have to follow this one because this one is in the book and this is the right one. This is for you, as information for you, because we have base. Base reacts with acid, but in the book acid reacts with acid. So this is wrong, because acid with acid, no, because we have a base. So if you have a base, so base reacts with acid. Okay, you got it now? Yes, but you have to follow this one. Yes, what we can do? Nothing. Okay, the second reaction with sodium hydroxide solution. This is sodium hydroxide. It is a base. Yes, So this is right in the book, and here it is right. Yes, this is the acid and this is the base. So acid reacts with base. Okay, so this is acid reacts with base. That is. So you have to remove H from the acid and OH from the base. Because this is base, that's why I remove OH from the base with H from the acid. They are removed as H2O. And just replace this hydrogen by sodium. Up to here, we have finished this chapter. Thank you for listening, and I will meet you inshallah in another chapter.